Docker architecture. So the Docker architecture consists of three major components. One is the Docker daemon, which basically does the work of a containerization. So it gets the instruction and it passes to the kernel, and then from the kernel it gets the response and do all those technical stuff, all those things which is happening in the server daemon, Docker server daemon. On top of the daemon, it provides a REST API, and when you want to communicate to the daemon, you will be communicating via the API. And for us to connect to the API, it provides a CLI. Okay, for a human want to execute some command and then do things, you can the Docker CLI is being used, and that's what we are going to have it. Okay, so the three components are Docker CLI, REST API, and the Docker daemon. Okay, and this Docker daemon manages four major components on the containers world. Okay, so the first thing it manages is called the container. So I told you container is nothing but the application and your own application and the respective binaries for the application to execute. So that is where the containers are all about. So it manages the life cycle of the container, like memory and CPU for it. Okay, manage the life cycle of a container. If you want to stop a container, start a container, maintain the status of the container, or if you want to communicate to the container, get the log from the container. So all these things it manages. The Docker daemon manages the container. And the next thing is images. So when I want to transfer a container from one mission to the another mission, okay, so I cannot really transfer this as a file. So we have a concept called Docker Registries. So Docker Registries are kind of a centralized area. We can push the images to the centralized registry, and from there you can download it. So images are nothing but the combination of binaries and your application data. So when you run the image, it will become a container. Okay. Think of a scenario of a Java code, right? You will be writing a Java code. When you build the Java code, it will become a binary, right? When you run a binary, it is going to run as a service in the operating system. The same way, in Docker, there is a concept called Docker file. We'll talk about that detail. So when you will write the instructions in the Docker file, when you build the Docker file, it will become an image. Okay, the image can be migrated to multiple operating systems, and when you run the image, it will become a container. So image, you can call it as a compiled form of Docker instruction. And the next concept which Docker daemon manages is called volume management. So the Docker was designed with a ephemeral policy in the mind. So any data which you store inside a container, if the container goes down, if you bring up the container again, or if you just bring it up again, the data inside the container will be lost. Okay, so we will talk about this 12-factor app development principle in the microservices scenario. So there it talks about a principle called you should design your application in such a way that even if a running process goes down, it should not impact the application performance or application functionality. Okay, so that is where this ephemeral policy comes into picture, where when a container is died, okay, all the data inside the container will be totally lost. Okay, but this may not be a very good scenario in the application which is writing some data, or especially in the database scenario. Database, it will be writing a data into a hard disk, right? So that is where the volume concept comes into picture. You can attach a volume to the container. Okay, even if the container goes down, the data will be retained in the volume, and if I bring back the container by attaching the same volume, I'll be able to retain the data. So this is called the volume management. And when I talk about volume management, there are multiple concepts available there, like sharing a volume with multiple containers. Okay, and in data itself, there are multiple types of storages available, right? We talk about a block storage. In the block storage itself, there are multiple types of storages available. That is fiber optics, NFS, network file share. Okay, in the block storage, there are multiple storage providers nowadays comes into picture, like Portworx or OpenStack or VMware storage provider. So there are n number of storage available. So Docker has to have the storage driver to communicate to the storage providers, and from there it has to get the storage and give it to the container. So these things are managed by the storage data volumes concept of the Docker. So Docker was designed in such a way that, okay, so it is in line with the microservices 12-factor app principle. So what is the need for that, right? So when I talk about, when I designing an application, right, there is a existing transactions going on, okay? Suddenly something happened, the data, the container went down. It can be anything, right? It can be a hardware issue, it can be a storage issue, it can be anything. But for a well-performing application, it should not impact the ongoing transaction, right? So the other process in a high availability scenario, the other process to carry forward the same instruction on a different container, and it should run it. Or is this concept of higher availability without impacting the transaction? In the microservice design principle, what we will do is we will not have a single database which is accessed across 10 different services. Every 10 service, in the 10 service, every service will have its own database. Okay. If it has to communicate, get information from the other database, it makes a call and get that. For that service, there will be very small application. So for a perfectly designed microservice application, a database should not go beyond 2 TB. Okay. So as microservice insist on splitting the application on the business logic, not on the technology logic. So if I'm having 10 services, it advised to have 10 database for it. You keep your database outside of this container platform. You keep a separate RDS and do that way. That will be a more effective way. Okay. After storage, the another important aspect which Docker has to take care of is called communication. So when I talk about microservice, there are multiple communication to happen, right? Like communication within the containers, okay? And then communication from the containers to the external world, and the communication from the external world to reach to the Docker container, okay? And adding to that, there is one more complexity which will come in the Kubernetes, right? Till now, Docker, we are talking about single machine inside that running multiple containers. So within the machine communicating to one container to another container is a different scenario. But when I add one more Docker host, if container one, let's say container A on Docker host 1 wants to communicate to the container B on the Docker host 2, it has to go in a different route because they are not within the simple network. There they have to come up with the overlay network and other concept. All these kind of scenarios are handled by the Docker network provider. Okay, so it supports communication within the containers, communication external communication to container, and from container to external network, and containers on different Docker host, how they are going to communicate. All these things are managed by the Docker network. On the 4 major components what Docker daemon manages. So container lifecycle, image lifecycle, volumes for persisting the data, and then network for enabling the communication.